Shall I start? Okay, so let us start the new problem. Note down this problem. So problem is we have three classes. So in last class we have seen a two class problem. So it was a two class problem. Now we are moving towards one more class, that is three class problem. Then this can be generalized further. So I need not then explain maybe 4 or 5 classes. So let us have a three class problem. Now here I call this as omega 1 and this as omega 2 and this as omega 3. So there are three classes: omega 1, omega 2, omega 3. So they are pen, pencil, and pen drive. Okay. So each object can take three different colors. So these three objects can take three different colors. So they are blue, green, and red. So pen can be blue, pen can be green or red, or pencil can be blue, green, or red. So like that, we have defined our problem domain. Now, as per our knowledge, we have probability that in a given set of objects, there are 0.4, that is 40% of the objects are pens, then 30% objects are pencil, and 30% objects are pen drives. So total is 1. You can note down. Right. Now, you are being provided a table where this vertically you have different colors, that is blue, green, red, and horizontally you have different objects, say pen, pencil, and pen drive. So this entry here is the probability that given pen, so when pen is given to you, its color is blue, the chances are 60%. So what must be this probability? This probability is talking about only pens. It is not talking about pencil or pen drive. So my domain is restricted. See what I'm saying? My domain is restricted to only pens. So these entries which are in this column are likelihood of pen. Okay, you can note down these words. You may get confused later on. So the column pen and the entries of probabilities here, they are all likelihood of pen. Now in second column, I am discussing about only pencil. So the condition is given the pencil, you can see here 3 times condition is same. Given the pencil, it is of blue color, it is of green color, it is of red color. What are the chances? They are 0.1, 0.6, 0.3. You can note down that the sum of these probabilities is 1. Say sum of this probability is 1. Now when I talk about third column, it is
Yes, sir.
talking about, this should be pen dry, right? This should be pen dry. This should be pen dry. So here I am talking about PDs. The probability that it will be blue is 0.3, probability that it will be green is 0.1, and red is 0.6. So again, sum must be 1. So the columns here, 1, 2, 3, they are talking about individual objects and the distribution of these objects for different colors. So they are talking about themselves. They are not talking about say pencil and pen, right? So this is called as likelihood. So the first column is likelihood of pen, second column is likelihood of pencil, third column is likelihood of pen drives, right? Now you see, question is, if a randomly picked object is blue, I have selected some object and it has uh, been observed that it is of color blue. Which is this object? This is my question. How to find out what is this? So what we do is we find out these three probabilities. What is condition? Condition is that x is equal to blue. That means given color or the parameter observed for a given object is blue, right? Then I am talking about whether this is pen, whether this is pencil, whether this is pen drive. So I have to find out probability for these three conditions. Object is blue, then what is probability that it is pen? What is probability that it is pencil? What is probability that it is pen drive? So that three quantities I am interested. So directly they are not computable. So you cannot find out them directly. We are going to take help of Bayes again. So Bayes will give me answer with respect to the likelihood. So this is the posterior. So we call this probability that given some feature, what is the class of that feature vector or feature? This is posterior. Okay, but we have information in terms of likelihood, then prior, and then evidence. So these three we can easily find out. Now how to find out? This likelihood is already given to you. This prior is already given to you here. Okay, so we need to calculate only this denominator, which is nothing but the evidence of the blue color. Okay, now how do I do it? So what I do is I write the numerator as it is because I know values of this. From table I can easily get. Now denominator is probability of selecting a blue or probability of obtaining blue in the problem domain. So I am not interested now what object is that. Irrespective of that, I am interested in color. So how many times blue appears in my problem? So I want to marginalize pen, pencil, and you can say pen drive. I am not interested in type of the object. I am just interested in blue. So what I do, I use sum rule. So this denominator is obtained from sum rule. So see what is done here. This is the first term where I am talking about pen and I am expecting blue color. This information is available in my table. Then multiplied by the prior of this. So prior of pen, how many times pens are appearing in the problem? This is also given to you. So these two things are already known. From that only you are calculating the first term. Then you go to the second term where you are talking about the pencil. Okay, so given the pencil, how many times blue color is appearing? Then third part is given a pen drive, how many times blue color is appearing? So in total, if you add all these three quantities, you will get the evidence of blue. You are interested in blue color only, so that you can obtain from this. Now thing is, you have to just substitute different values and you will get the corresponding probability. So this we have defined. Now I substitute corresponding values from the table. So like this. This is already known to you from the previous table. Okay. Say if I start to write here itself, then I think you can make more sense. Somewhere I should write here. Suppose I write here. Say first is given pen, what is chance that it is blue? Given pen, what is chance that it will be blue is 0.6. You can see here. Multiplied by prior of the pen. What is prior of the pen? Pen is omega 1, so prior of the pen is 0.4. now divided by the first term is same thing, 0.6 into 0.4 plus given the pencil, if it is of blue color, then it is 0.1, chance is 0.1 multiplied by the chance of the pencil itself. So pencil is, I think, of 0.3 plus. Then you have a pen drive with blue color. So go to the column of pen drive and see what is blue color chance. It is 0.3 multiplied by chance of pen drive itself. So chance of pen drive is 0.3. Okay, so if you solve this, you will get answer as 0.67. So pen, what you obtained is this probability. This is posterior probability. What it is talking about, if given object is of blue color, chances that this will be pen is 0.67. Okay, so that is now known to us. Then in the same way, we can use Bayes for getting the probability for pencil. Okay, object is blue, then what is chance that it is pencil? So I hope you can solve this now and substitute proper values. Then you will see that this is 0.08. Then I go for the third category, that is pen drive. Given pen drive, sorry, this should be blue. Given it is blue and it is a pen drive, given that object is of blue color and it is a pen drive, calculation shows it is 0.25. Okay, now we have all three probabilities. You can check that sum must be 1. If this is not 1, then there is a problem in our computation. I hope this is 1. Then select max probability. Select max. So selecting max is 0.67. Then my decision based on this is that given object, if it is blue, then it is likely that this is a pencil. Sorry, pen. It is a pen. So my decision goes with pen. So I take the decision based on the posterior probability. You see that this posterior probability is 0.67. So total probability is 1. You can see that 1 minus 0.67. So how much is this? I think 0.33. So this much is error in my decision. It can be still something else. What I'm trying to do here is I'm trying to minimize my error. My error is based on maximum probability. So there is a 0.67 chance that, or 60%, 67% chance that the given object is pencil. So I'm going with this decision, or my computer is going with decision of that it is a pen, but there is a still chance that this will be a wrong decision, and the chance of a wrong decision, that is probability of error, is 0.33 or 33%. Okay, so there is no guarantee that this should happen, but there is a quite good chance that it is a pen. So this is how the probability works. Now homework you can take: if selected object is of a red color instead of blue, if it is of a red color, which type of object is this? What should be your decision if you find a red color object? You do a random selection and you find a red color object, then what should be your decision? The second part, same procedure. So I hope you will solve this because this will give you a very good practice, and try to solve on your own. So if selected object is green, what is this type. So this will be a very good exercise to understand the basics of machine learning. Now we move on to next problem. You note down this problem. So what we have done, we have measured, say, diameters of two objects. So only one, you can say, one parameter is being measured for the object, say like this. So I am measuring diameter of this plate and measuring diameter of this bucket. Okay, and I have collected this samples. So the list of samples is here. So this is my total sample list for all the samples which are of the type plate and say this bucket. So we generally call this as X. So this is my X set. Now out of that, if I separate plate measurements, okay, so I separate plate measurements, I can call that as class 1. So I have collected all the plate measurements. So these are different plates, okay, and just measured their diameters. So there are 8 plates in my training set. They are of this dimensions, and then I have a bucket set called as class 2, and then I have measured the diameters. Okay, and there are such 7 samples of buckets. Now if I plot this histogram for different measurements, so you can see there are some discrete values available here, maybe 0.1, 0.1 here, then how many times 0.1 is appearing, I can just plot here, then how many times 0.2 is appearing, 0.3 is appearing, maybe 0.5 is appearing, I can just keep on counting and divided by total number of samples. Then this kind of graph you can obtain. This is called as histogram of the probabilities. Now question is, if X test is 0.1, if there is some new object coming to the computer, it may be like this, I don't know what is this, but now computer want to find out what is this object. So what is the procedure? The procedure is you will measure diameter of the new object, and the diameter of new object is found to be 0.1. Then you have to say whether this is plate or bucket. Okay, so you have to take a decision with only one measurement, and you can refer to the data here which is given to you. You can refer to all this data. Now what we do, we again use the famous Bayes rule to solve this problem. Now what is this? Probability of some X measurement given omega 1. This is 6 by 8. So what is this? So within omega, so what is measurement here is X is equal to, I think, 0.1. So X is equal to 0.1 is my measurement. How many times in omega 1? So this is my omega 1. How many times in omega 1 0.1 is appearing? You just count 1, 2, 3, 4, 5 and 6. So 6 times 0.1 is appearing out of 8 times. So 6 by 8 is called as likelihood of plate. Okay. Then I can find out how many times plates are appearing in my problem domain. So out of 8, out of 15, 8 times plates are appearing. So out of 15, 8 times plates are appearing. So it is 0.53. Then I want to find out the evidence of point 1. How many times point 1 measurement is appearing irrespective of whether it is bucket or whether it is plate. So why I am doing all this? Because I want to find out probability of plate given probability of plate, or I should write in terms of omega, then I can write in terms of omega, probability of omega 1 given the measurement x is equal to 0.1. So this I want to find out using base. So what I do, I just find out probability of x is equal to 0.1 given omega 1 into probability of omega 1 divided by probability of x is equal to 0.1. So I want to say compute this. Then I can compute probability of omega 2 given x is equal to 0.1. So this will be, you have to just flip this probability where you can say inside this bracket, whatever is there, you just flip it. So it is x is equal to 0.1 given that omega is omega 2 into probability of omega 2 divided by again probability of x is equal to 0.1. So I want to solve this or find out these probabilities, then I will take a decision. So to do that, I need to find out this. I need to find out this from likelihood and these priors. Okay, then I can take a decision. So here we have computed probability of x given omega 1. So probability of x given omega 1 is computed as 0.75. Then probability of omega 1, how many times omega 1 objects are appearing in total domain. So it is 8 by 15. Then I compute probability of x is equal to 0.1 itself. So this is equal to 6 by 8 into 8 by 15. This one. How do I do it? So you can say probability of x is equal to 0.1 given omega 1 into probability of omega 1 plus, so this I am talking about x equal to 0.1, probability x equal to 0.1 equal to probability of x equal to 0.1 given omega 1 into probability of omega 1 plus x is equal to 0.1 given omega 2 into probability of omega 2. So again I am using sum rule. So denominator is always using sum rule. You can note down this thing. So substitute these values, you will get this to be 0.46. Okay, so this will be 0.46. Now everything is known to us. We can use base to find out what is probability of omega 1 given x is equal to 0.1. Okay, now this uh, first quantity here is 0.75, that is written here. Then chances of omega 1 is 0.53, which is calculated here. Then denominator is 0.46, which is calculated here. So in total, I know that it will be 0.86. Now this is called as posterior, or chances that the object which you have measured of length or of diameter 0.1 belongs to omega 1 is 0.86. Now my question is, what will be chance that it belongs to omega 2? So we have found out right now that the given object which measures zero point 0.1 belongs to plate category to the extent of 86%. So 86% chance is that whenever you measure 0.1 diameter, it is a plate. Now what is chance that it belongs to category bucket? Okay. So you can do this very easily. Since this is a two class problem, I can just subtract from 1 this 0.86, so this will be 0.14. Or you can solve this. Try to solve this for your betterment, so that this will be explaining you how you can do this. So I'm just repeating here, x is equal to 0.1 omega 2 into probability of omega 2 divided by the evidence, it is x is equal to 0.1. So you can do this. You have already calculated this denominator. Denominator is 0.46. Now, can you find out this probability of x is equal to 0.1 given it is omega 2. So within omega 2, this domain is omega 2. This domain is omega 2. How many times 0.1 is appearing? So you just see here only one entry is there. And there are other entries of other diameters. Say there are how many entries? 1, 2, 3, 4, 5, 6, 7 entries. Out of that, only one entry is of 0.1. So 1 by 7 is the chance of obtaining measurement 0.1 in bucket. So I write here 1 by 7 multiplied by the chance that bucket will appear. So there are total 15 objects in my list, say 8 here and 7 here. So total 15 objects. Out of that, 7 are, I think, omega 2. So if you calculate this now, it should come 0.14. Okay, you can verify this. You can directly do like this, or you can directly do like this. Now question is, what is your decision? You have now two probabilities. Probability that given object is omega 1, it is 0.86. Probability that given object is omega 2, that is 0.14. So use Bayes and take a decision based on max. So I will go with a max probability, that is 0.86. Then my decision is omega 1. So I will declare that if you observe a new object of size, diameter size 0.1, then it must be plate. So my decision is plate. So doing so, how much is the probability of error? Probability of error is 0.14. Okay, remember that nothing is perfect. So we are taking just chances, and we are sticking to the chances which are maximum. Okay, by maximum, it is the case with the help of our training data. So this is my training data. So based on this training data, I am taking the decisions. So I am hoping that same thing will happen again. So that is my assumption. So many times assumptions do fail. So obviously there is a chance of error. So I hope you have understood these two problems. Then I have to move to the next difficulty in doing or solving these problems. And that is based on the parametric method. So the method is called as parametric method. So that is the second step in Bayes. So what you have observed here is this particular in this particular problem, I just rub this thing. So clean that thing. Now you see I can do this calculation, that's fine. Now suppose I say the new measurement is maybe of this size. Now the new coming measurement, which is never seen earlier, is of size 0.15. So you can go through this list. There is no x is equal to 0.15. If you've traveled through this list, there is no x is equal to 0.15. If there is no evidence of this 0.15, then you calculate, say, like this, then the probability that it is omega 1 is 0 and probability that omega 2 is 0. So you cannot take a decision based on this. Since there is no evidence of 0.15 in my list, this is going to happen. Okay, so what is the solution for this? Shall I go ahead like this? So then I cannot take the decision. So what we try to do is we try to fit a model, data model, based on the available data. So what we do, we assume distribution, data distribution model to solve this problem. So what it means is that based on the data, say based on this list, based on this list for omega 1, based on this list for omega 2, I try to fit a model of data. So a common thing is always follows. I assume that my data distribution is of normal form, or it is of the nature normal distribution. So what it means is that, so it is of like a bell shape. So there will be a mean of data and there is, say, variance for this. Okay, there is a variance in both sides, plus or minus. So sometimes we may call this as mu. So what I do is, based on the samples, say based on this samples 1.1, 0.1 and so on, what I do, I just find out mu by adding all these numbers like this and divided by 8. So I just compute mean of this data. So mean of this data is computed, that will be here. Then I take difference from mean and square it, add it, so I get the variance, and that will be here. Okay, so a normal distribution you can define with the help of mean and variance. If this is done for omega 1, I can assume again a normal distribution for second group, that is, I can call this as, say, 1 and 2. I can do this for class 1 and class 2. Now what is advantage? Earlier I was not having the information about, say, if this is, these are some distributions of samples, and suppose this is 1 diameter, this is 2 diameter, say 0.1 and 0.2. This information is available, and information about this center value 0.15, say earlier it was not available in my list, say there is no 0.15 here. Okay, now based on this data model that I have fit on this available data, I can now find out that, okay, this must be probability of 0.15. So I can solve now for any kind of, you can say, measurement. Say this means 0.08, I can solve. So earlier this was not possible. So this will be possible if I try to fit a model on my data. So this kind of computation, or this kind of method based on data distribution, so these methods based on data distribution are called as, or model of data distribution are called as parametric method. since I can define the whole distribution of data by defining these parameters only. Okay, so if I define mu, or if I compute mu and say standard deviation, sigma, or variance, I can find out any kind of probability based on these two numbers. And the most common in this is normal distribution. So we'll see details of this later on. Don't get panic here. For time being, you can just check that this is one-dimensional normal distribution. This is two-dimensional normal distribution. There is variable x1 and there is variable x2, and you can imagine that this is of this bell shape. Okay, you can imagine this is of some bell shape, maybe like this. Now the normal distribution is given by, the formula is in front of you, 1 by twice pi sigma square, where this sigma is your standard deviation and sigma square we call it as variance. E to the power, so 1 by twice pi sigma square, square root of that, into e to the power minus 1 by 2 sigma square x minus mu whole square. Okay, x minus mu whole square. So this is the formula for computing the probability here for normal distribution, or actually this is the normal distribution model. So this is the mu computation. You can directly compute average of given samples. You can do this, and this is the formula to compute standard deviation. So you compute standard deviation like this: x, the given sample, minus its mean. You take square and you do all this for this step for all samples from I equal to 1 to n. So n stands for number of samples. You add all these squares, different squares, and then take average. Once you take average, you take square root of that. If you don't take square root, it becomes sigma square. This is called as then variance. If you take square root, then it is standard deviation. Okay. Now same thing you will see here extended for multi-dimension, say d dimension. So 2D figure is like this. You can extend this concept of normal distribution for d dimension. So formula is little bit changed. So 1 by twice pi d by 2 into sigma, this matrix. So determinant of this, square root of this, into e to the power minus half x minus mu transpose sigma inverse x minus mu. So we are going to solve problem based on this. So don't worry right now about this. So this is the formula for multi-dimension or d dimension. Then in the same way you can compute mu for this. Now here these are vectors. So whenever I write capital X, it is a vector. You can see there is a small x here. That means it is one dimension. And n is again total number of samples. Now this sigma here is called as covariance matrix. So this is called as covariance matrix. And this is computed like this: x minus xi minus x. So this is a mean vector into xi minus mean vector. So these two things are vectors and it is transposed here. That means A into B transpose. So this is going to be a matrix. Now suppose A A is of dimension 4 by 1, that is 4 rows and 1 column, and B is also say 4 by 1. So transpose of B will give you 1 by 4. Say B is of dimension 4 by 1, A is of dimension 4 by 1. So if I take B transpose, then it will be 1 by 4. And if I do multiplication of these two vectors, it is called as outer product. So this is called as outer product. This will result into a 4 by 4 matrix, and that is here called as sigma or covariance matrix. Okay, so there are two types of vector multiplication. Normal vector multiplication is called as actually inner product. So it is 4 by 1 multiplied by, again you can say 4 by 1 transpose multiplied by 4 by 1. So this will be 1 by 4 multiplied by 4 by 4. So this will give you one quantity or one number. So whenever you do inner product, you will get only one number. Whenever you do outer product, you will get a matrix, and in this case this is called as covariance matrix. Okay, so we will take a problem so that these things will be clear. So I think I should stop here. We will start the discussion on this in next class.